when we start putting transformations together, there are a few things that we have to remember that are different than if you're just looking just at reflections or just stretches or just translations. This equation, y equals maybe a negative, maybe a positive, AF of, and again, this could be positive or negative, B x minus h, oops, that should say plus k. If there's a negative in the front, that's a reflection in the x-axis. So anytime you have a function that has a negative in the front, it's reflected, it's a vertical reflection in the x-axis. How about the A? Vertical stretch. Whoops, not that. This. Vertical stretch. Whatever the A value there, that's the stretch factor. So you'll say it's stretched vertically by a factor of A, whatever number that is. And then I'm going to go to the K next because that's the other part that's outside the function. Right? This is the function, F of all of this stuff. What's outside is the reflection in the x-axis, the vertical stretch, and the plus K, which is the vertical translation. So all of the vertical stuff is outside the function. Reflection, stretch, and translation. And then inside the function, so after the F and inside the brackets, you get all the horizontal things. So the negative, that's the horizontal reflection in the y-axis. The B is the horizontal stretch, but remember we say it's a horizontal stretch by a factor of 1 over B, the reciprocal of that. And then the H is the horizontal translation. The other thing that I have here at the bottom is the mapping rule. And this is the way we write these things in a mapping rule. XY maps to negative, if there is one, 1 over B, x plus h. So remember, reciprocal of the B value and the opposite sign of what you see in the equation for the horizontal translation. So it says x minus h, we put it in here as x plus h, and then negative a, y plus k, those ones don't change. Here's the first one we're going to do. Sketch a graph by following these 3 steps. I know that's kind of small, but I wanted to leave lots of space to do the work. Here's the equation, and the first step is describe the transformations. That's the first thing we're going to do. You don't necessarily have to do that in order to sketch the graph, but this question is asking us to do it. So when you look at that equation, y equals negative 2, 1/3 x squared plus 1, what would you say the transformations are? The transformations of the parent function, which is y equals x squared. Okay, so here are the transformations we have. Reflection in the x-axis. Oh, I didn't put the x in there. Oh, I'll fix that. Reflection in the x-axis, that should say. That's the negative in the front, so that's a vertical reflection. Oh my gosh. You guys could have told me when I made a mistake. I was looking at this one. For the horizontal stretch by a factor of 3, vertical translation of 1 unit up, but I didn't even notice the 2. You guys did, but then you didn't stop me. So what do you do with the 2? I know, but you said, but when I told you were wrong, you just agreed that you were wrong. What is it? Okay, so tell me what that reflection is, the 2. Vertical stretch by a factor of 2. So then the second question asks us to write a mapping rule. This is what's going to allow you to make the graph. And sometimes you'll just be given, like in a multiple choice question or something, a point, and you have to transform just that one point. And the mapping rule is also the way to do that. If the question was multiple choice and it was just like to sketch this graph, well, you just punch it into your calculator, right? That's what I would do. But if it's asking you to just transform a point, or right here we're doing it without a calculator, then we need to make a mapping rule. So for the mapping rule, we need to look at which of those values that are in there affect the x. And the only one that's horizontal of these is the stretch by a factor of 3. So we're going to go 3x. Everything else was on the y, right? The vertical reflection in the x-axis, the vertical stretch, and the vertical translation. Those ones are easy. We're just going to write them in the order that we see them. So we're going to go -2. And then the y, the function itself is like the y and +1. That's the mapping rule for transforming this function. So what I'm going to do, then step 3 asks you to make a table of values. I'm going to make a table of values for the parent function, which is y equals x squared. Do you know what the table of values for y equals x squared is? We'll just kind of look at those values close to 0. So let's look at -2, -1, 0, 1, and 2. All you have to do to get the y values? Square them. So 4, 1, 0, 1, 4. Then we're going to transform all of those points. And the mapping rule tells us exactly how to do that. It says take each x value and multiply it by 3. So all of the x values now are multiplied by 3, so -6, -3, 0, 3, and 6. That's how easy it is once you have the mapping rule. For all the y values, multiply them by -2 and then add 1. So that's going to be -8 plus 1, -7. And we'll go 1, that's -2 plus 1, so -1, 1. And then we've got, -1 again. And -7 again. We could then plot those points and we'll end up with a graph that looks like this. -6, -7, -3, -1. If you look on the graph, there are those points, -6, -7, -3, -1, 0, 1, 3, -1, 6, -7. All of those points are there. So let's have a look at this one. When I look at that equation, I notice a problem, and it's that it's not in transformational form. Because if you remember transformational form, inside the brackets it had negative or positive b, and then a bracket, x minus h. And so what that means is that the translation has to be the only thing inside the brackets with the x. And right now with the x we have the translation and the reflection. And so to deal with that we need to factor out that reflection. So the first thing I'm actually going to do is change this equation to y equals 3, the absolute value of negative, and then a bracket x minus 2 minus 4. So transformations here, vertical, stretched by a factor of 3, horizontal, reflection in the y-axis, horizontal translation 2 units to the right, and vertical translation 4 units down. Then when we write the mapping rule, xy maps to, think about which of the things were horizontal. The reflection, so negative x, and then this translation to the right, so that means I need to do plus 2. Right? The ones that are with the x switch. If it's -2 in the equation, it's +2 in the mapping rule. And then with the y, it's 3y minus 4. Table of values. The parent function was y equals the square root of x. So I'll just use those same values, -2, -1, 0, 1, and 2. But then take the absolute value to get the y values. So these will be 2, 1, 0, 1, and 2. If you don't know the table of values for the parent function, then just use your calculator to find it. But you can probably figure them out pretty easily. We'll transform that using the mapping rule. So it says, multiply the x values by -1 is really what that's saying. And then add 2. So -2 becomes 2, plus 2 is 4. -1 becomes 1 plus 2, that's 3. 2. And this is going to be -1 plus 2, so 1 and 0. There are the new x values. And then the new y values, multiply them by 3 and subtract 4. So 2 times 3 is 6, subtract 4. 2 times 3, -1, -4, -1, and 2. We end up with this graph that has those points, hopefully. -4, 2. Uh-oh, I have a mistake somewhere. Oh, sorry, 4 and 2, that's why. Yeah, 4 and 2 is there. 3 and -1, there. 2 and -4, 1 and -1, 0 and 2.